This is the second video on GCSE Venn diagram questions, and we're dealing with the set notation for Venn diagrams, and it might be the last video. We also need to deal with questions where you have to draw Venn diagrams and there is set notation involved as well. We'll see how we get on, see how long this takes, and I might split this into two. So there's a few bits that we need. First of all, this thing is it's a Greek letter. I think it's a zeta or an eta, but I'm afraid I've forgotten exactly how we pronounce this, but it doesn't really matter. It's a Greek letter, and what that means is everything that's going in the Venn diagram. Okay, so if that was, I could say the whole set is the set of numbers. I could say, right, I'm going to put even numbers up to 100. That would mean that my Venn diagram is going to contain all the even numbers up to 100. And these squiggly brackets here are what we use to describe the set. So this is everything I want to put in my Venn diagram. If I want to draw a Venn diagram and inside it I want to have all the even numbers up to 100, then I write this symbol, the universal set is another name for it, is equal to, we read this bracket as the set of, and then inside that we write a description of everything we want. So another example would be everything I want in my Venn diagram is the set 1, 2, 3, 4, 5. And I want to put those numbers somewhere in my Venn diagram, okay? So whatever's in this set is going to go somewhere in your Venn diagram that is somewhere in the rectangle. Okay, it might go in one of the circles, it might go in an overlap between two circles, it might go in an overlap over three circles, or in one of these areas here. It might go outside the circles, but it has to go somewhere in the rectangle. The rectangle, it contains everything that you're interested in, and everything you're interested in is called this. Now we can actually sort of ignore that. We just label the rectangle with that symbol, and we never really need to know much about it, apart from in the question it will say this squiggle is equal to this, and that means the numbers you have to put in the diagram. So I might call a set something like A or B. So if I have a Venn diagram like this, then I can have a set, and I'll call it, that is set A. So I could say set A is equal to the set of, I don't know, square numbers. And that would mean on my diagram, any numbers that are in the Venn diagram in the first place, so any numbers that are in this set or in this set, whatever I decided to put in the Venn diagram, if they're square numbers, they're going to go inside set A. So I might have a diagram that would look like this, set A and set B, and I could say set A is the set of square numbers. I could say set B is the set of prime numbers or odd numbers or cube numbers, and then whatever fits the description for set A goes inside this diagram, whatever fits the description for set B goes inside this diagram, whatever fits the description for both goes inside this part here, okay? This is called the complement of A, spelled like that, and it's also called not A. So guess what it means? It means everything that's outside of A. So on our Venn diagram it would look like this. Here is set A, maybe there's another set there called B, but everything outside of set A would be everything like that. So this part is in set A and set B, but it's in set A crucially, so that's not in the complement of A. That bit there is in set A and nothing else, so that's not in the complement of A. Everything else is in the complement of A. The complement of A means it's not in set A. A intersection B would look like this. I'll just squeeze a little diagram in. Hope you can see this one. I could have set A and set B. This symbol is read intersection, and the intersection you can think of it as and, you can think of it as the overlap. Okay, a lot of people remember intersection and you know, if you say fish and chips, you often pronounce it just as an n, don't you? Okay, so an intersection with an n, it looks like an n symbol, and it's the and. Okay, A and B. We often pronounce it as an and it's the overlap. So A and B means it's in the circle for A and it's in the circle for B. It's in the overlap. This symbol here is pronounced union, and we say or, and that means set A and B all together, okay? So when we say or, in maths, I mentioned this in the previous video on drawing Venn diagrams, we mean something that can fit set A, or it can fit set B, or it can fit the overlap. So it could be in this part here, it could be in this part here, or it could be in this part here, okay? These things, A or B, these things that are in the intersection A and B are still counted as in the union, okay? So it's everything that's in the circle for A and the circle for B. So again, just to recap, in real life you might say, would you like a biscuit or a chocolate bar? And you're not really offering somebody the option of a biscuit and a chocolate bar. So in maths, if you said, would you like a biscuit or a chocolate bar, mathematicians would interpret that as you have three options, either just a biscuit, just a chocolate bar, or a biscuit and a chocolate bar. All of those three possibilities are covered by this union symbol, or just the word or in maths. Okay, outside of maths, if you say, would you like this or this, we actually mean, would you like to have option A or option B, but we're not really offering both a lot of the time, okay? So what sort of questions can they ask us to do? The first thing they can ask us is this sort of thing. They can say, okay, here's a Venn diagram with three sets on it, A, B, and C. And they can say, where is A intersection B intersection C? So the way you could deal with that, you might want some different colours here, or you might just want to use different kinds of colouring in. So A intersection B, so A is this set here. I'm colouring in everything in the circle for A, okay? B is this set here, and I'm colouring it in or shading it in with lines going in the opposite direction. So it's that bit there. And then C, I'll do in orange here with lines going in this direction. So there's three sets involved. There's A, B, and C, and I'm colouring each of those in. Is an intersection, so let's have a look at our notes. Intersection means and, it means the overlap. So the overlap of the shading like that, the shading like that, and the shading like this. Okay, and the overlap, if you can see it, is this bit in here. Now, it's obviously easier if you've got three different colours to do it in, but hopefully you can see that's the only part that's got all three different colours of shading in. So A intersection B dash, so let's draw that one. We've got a Venn diagram with just A and B in this case, there's no C in the question. So we've got A here, B dash here, so I'm going to colour A in with shading in that direction. So that is A, oops, sorry. I've got A and B. Okay, so A is there. B dash means not in B, so that would be this part outside, and it would also be this bit of set A. This bit is in the circle for B, so we can't include that. This bit's in the circle for B. So B dashed, I've coloured in orange. Intersection means the overlap. Okay, so only where those things are overlapping. So now that bit there is A intersection B dashed. Okay, what about A dash union B dash? So let's draw a Venn diagram. There's only two letters involved, so I'll draw a set for A and a set for B. A dash, I'll do it in blue pen, is everything outside of A. So this stuff here, okay. B dash is everything outside of B, so that's this stuff here, including this part of set A. Now, what I've got now is this union symbol, so let's have a look at the notes. Union means all, it means all together. So not just these bits, not just these bits, not the overlap between the two of them, but everything which is coloured in either in blue or in orange, okay? So in that case, I'm going to have this bit, because that's in blue and orange. I'm going to have this bit because that's in orange. I'm going to have this bit because that's in blue. So in this case, I think I'll just draw my diagram out again to make it a little bit clearer. A dash union B dash is going to be everything apart from that little intersection there. That little intersection there is staying blank, but everything else is in A dash union B dash. So you think to yourself, what's in this set, what's in this set, and if there's 3 in a row, what's in this set, what's in this set, what's in this set? Shade them in different colours. If there's an intersection symbol, then it's the overlap. If there's a union symbol, then it's all the bits you shaded in all together, any colour at all.